Okay, so this is a video by special request for Softpick, the GOAT. Okay, so pretty much it's stoichiometry. So find the final grams for each molecule, stoichiometry. So we are given this setup, 2Na3PO3 plus 3K2SO4 goes to 2K3PO3 plus 3Na2SO4. So, and we are given that they start with 50 grams per reactant. So our first step, well, we have to find the moles of our reactants. So this is 1 mole over, and then we can go to our periodic table and find the mass. So how do we find the mass? Well, it's just 3 times however much the mass is of Na plus mass of P plus 3 times the mass of oxygen. So Na mass is 22.99 times 2, right? Then P mass, phosphorus, is 30.97, and then oxygen is 16 times 3. So we get all these, and let's add these up, and we get 147.9. So we can plug this in, so 50 divided by 147.9, and we get 0.3381 moles. And we can kind of separate these into columns because that's more helpful. Okay, now the next one is 1 mole over, and then again, fine, same thing. So it's 2 Ks, so K is 39.1 times 2. S is 32.06. And then O is 16, so 16 times 4. All right, now we add these all up, plus this, we get 174.3. 50 divided by 174.3, we get 0.2869 moles. Now, we have to find the limiting reactant. Well, how do we find the limiting reactant? It's whatever there's less of. So we have to do this divided by the coefficients. So, well, already we don't even have to do that. We can tell that 0.2869 is less than 0.3381. So it would be this divided by this and this divided by this to see which number is less. And we can kind of already tell that this number is less. So this, let's star that because that is our limiting reactant. You have to identify which one is which. Now from there, we can use our stoichiometry with our coefficients to find the moles of these two. So it's where you're going from, where you're going to where you came from. So we're going to 2 and we're coming from 3. So it's going to be 2 over 3 times limiting reactant, which is 0.2869. And this comes out to 2 over 3 times 0.2869. This comes out to 0.1913 moles. And then same thing here, where you're going to where you're coming from, which is 3 over 3, which also is 1. So 1 times 0.2869, which comes out to 0.2869 moles. Now, we have all of these moles. So we have to find the final moles. So this obviously is going to be all used up. So this comes out to 0 moles, in other words, 0 grams, right? Because it's being all used up since it's the limiting reactant. And then we have to go here. So not all of this 0.3381 moles is being used up. We have to, again, use stoichiometry to find out how much of it is actually being used up. So it is 0.3381 minus, same thing. It's where you're going from, where you're coming from times that. So where you're going, 2 over 3 times 0.2869. Right, so and then that is our final moles, so we can do that, 0.3381 minus, which we just did it here, 0.1913, and we get as our final moles 0.1468 moles. Now 0.1468, right, and then we have, if we're finding the final grams, right, we have to multiply it by, instead of 1 mole, 1 mole's at the bottom, so 1 mole. And we already found the formula weight, so it's 0.1468 times 147.9. So 0.1468 times 147.9. and this comes out to 21.71 grams. This, like we did, 0 grams. Now to find these, we have to do 0.1913 times the formula weight. So K3, so 3 times K, which is 39.1. P is 30.97. And what else? Oxygen is 16. So 16 times 3. So let's add all these up. That plus that plus that. We get 196.3. So let's do that, 0.1913 times 196.3. This comes out to 37.55 grams. And finally, we have this one, 2869 times, once again, find formula Na, 22.99, 22.99 times 2, because there's 2 of them. S is equal to 32.06, and there are 4 oxygens, so 4 times 16. So once again, let's add all these up. Boom, boom, and boom. We get 142.04. And the final grams comes out to 0.2869 times 142.04. Comes out to 40.75 grams. So that is how to do that. Now we can check this actually so we started with how many grams initially in total? Well, we started 50 here, 50 here. How many total grams is that? Well, that's 100 total grams. Now we can add all these up to see if they equal 100. And if they do, then we know we did it right. 21.71 plus 0 plus 37.55 plus 40.75. Exactly 100. That's just sig figs, probably 0.01. So all of these combined equals 100 grams. So we know we did it right. Okay, our next question asks to find the empirical formula of this molecule. So we are given that 40% of the molecule is carbon, 6.7% of the molecule is hydrogen, and 53.3% of the molecule is oxygen. So how do we go about this? Well, all of these obviously add up to 100, so we can set them convert them to grams, and we can find the moles from there, normalize, and then finally find the empirical formula. So how do we do that? Make this grams, grams, grams. So 40.0 grams is carbon, and we can find the weight of carbon with our periodic table, which it comes out to 12.01. We can do 6.7 grams of hydrogen, 1.08 to find the moles, and 53.3 grams, 1 over, oxygen is 16.0. Now, that's how we find the moles. So 40 divided by 12.01, you get 3.3305. For here, we don't do sig figs, we just run it out to see pretty much, you go to 4 decimal places, and you don't round at all. You just simply do that, because we're normalizing here. Then 6.7 times 1.08, we get 6.7536. Then 53.3 divided by 16, we get 3.3312. Now, we have to find, once again, the limiting reactant, you can call it. And so you divide the lowest number by itself. Okay, thank you. No, give me 1 second, please. Okay, so then you divide it by the lowest one. So the lowest one here, well, it's 3.3305. So divide that by itself, 3.3305. So that way you can get equal to 1, because anything divided by itself is 1. Then you divide everything else by this, 3.3305. So this, we can just plug in our calculator, 3.3312 divided by 3.3305. It equals around 1, so 1, and 6.7536 divided by 3.3305 and it comes out to about 2. So we can do that, and from there we can find the empirical formula, which it comes out to be. So for this is carbon, this is hydrogen, this is oxygen, so C1, which we don't need a subscript, H2, so the 2 goes to the subscript, and O1. So this is our empirical formula. That's how you do that.